Okay, so let's do an example in power electronics using Psim. Okay, so are you seeing this handout, lab handout? Experiment number 0, which is initiation in simulation using Psim. Okay, so we are going to do something similar to what have we done in the lab, which is single phase, half wave, full wave rectifier. Then you can do the second lab that I give you. You can do it by yourself using Psim. So, okay. Good. So the objective of this lab is to observe waveform at the output of half wave rectifier with and without filter to measure DC volt, DC current, ripples factor, etc. Okay. So the data, of course, here we must give you the data, okay, to do your simulation. The source voltage here is 10 volt peak value, 50 hertz. Resistor, we have two resistor, 551 ohm, and okay, we can use the same parameters as we have done in the lab. Let's use 500 resistor, capacitor, 47 microfarad. Second capacitor is 470 microfarad. So let's start with the half wave rectifier with R load. Firstly, the first step is to connect the circuit as shown in the figure using Psim. Okay, so you can see in this circuit we have a voltage source, we have a diode, we have ammeter, we have a resistor, and we have a volt meter, or here in Psim they call it voltage probe. Okay. Now, lab 0 is just, you are not asked to do it, okay? It's just initiation, okay? You do only lab number 2. Okay, so let's start connecting this circuit. Okay, so let's close it, start from the beginning. Let's open Psim again. Okay, so this is Psim, create a new file here. Okay, firstly, what we have in this circuit, we have voltage source, a diode, a resistor, and measurement devices. So we can bring voltage source here. Okay, there is a sinusoidal voltage source, there is triangular voltage source, waveform, as you know. There is a DC source. Let's bring an sinusoidal voltage source. A diode, you can find it here. You can rotate it here. This is a diode. And we need also a resistor. Okay, so this is the main element in the circuit. However, here we add some measurement devices. As you see here, we have a voltage probe and we have a current probe. So we use, as we use in the lab, we use probe to visualize. Okay, to visualize different signals. So here we use those probes, of course, to also to visualize our signals. So this is the current probe, and this is voltage probe. Okay, so now we can connect them, as you see, from the source to the diode. Then we pass by this current probe. Then we connect it to the resistance. Then we connect it back to the source. Okay, and of course the voltage probe is connected in parallel with the resistance, which is the output of this circuit. And this is, you can see here we have now a single phase half wave rectifier. Okay, so we have a voltage source, we have a diode, we have a current probe which is connected in series, we have a voltage probe which is connected in parallel, and we have a resistance. So now also what we are going to bring, we bring the simulation control. This is in this menu, simulation control, and we bring this clock. So according to this clock, we can configure time. Okay, we can configure time. For example, let's select 0.1. Let's see a such number of periods. Let's select 0.1. Okay. Now let's configure our elements. For example, the voltage source here is 10 volt peak to peak. Okay, double click, so we select 10 volt. Frequency is 50 hertz. The resistance, for example, we double click, we make it 500. Let's make it 500. Okay. The diode does not need to configure it. And as I said, those probes are used to visualize. So those signals, those probes work with the same view. I will explain it step by step to understand it. Now, when we finish the circuit, how we can run simulation? We have this button here. I hope you are seeing it. Here we run simulation. Okay. Are you seeing this button here? Okay. Are you seeing this button here? Run simulation. Okay. So let's run simulation. Okay. So because we don't have a long time, I just select here in 0.1. Okay. 0.1 second. So then we run simulation. After we run simulation, if we don't have any errors, the scene view run automatically. Okay. You can see here those variable I2 and VP2. Okay. Those variables came from the probes. Okay. For example, let's go back. Let's double click on. So these probes, as I said, we work with the same view. Okay. So if you want to visualize this signal, any signal, we use voltage and the current probes. Okay. So let's double click. Let's write, for example, here current. And here double click. Let's write here voltage. Okay. So when we run simulation, I found those variables here. So they work with the same view. For example, if you want to display the voltage, I select the voltage, push, add. Okay, so here I can see the voltage. Okay. Is it clear or should I repeat it? Okay. You have an error. You should run the patch. Okay. Okay, so I will repeat it. Okay, let's talk about the technical problems later. Okay. So let's here talk about simulation, then we talk about the technical problems later. Okay, so I will close this scene view. Okay. معليش. Let's speak in Arabic. ولا بالدرجة. Okay. So if you want, أنا كنحب, if you want to visualize any signal, for example, عندي current ولا voltage. Okay. I must use probes. You don't have to change their names. Okay, ماشي مشكل يعني تقدر تخليهم as they. Okay. So, for example, نحي هنايا. Let's remove those probes. Okay. I can run the circuit without probes. Okay. For example, like this. Okay. But I don't have any variables to display. ما عنديش, because I didn't connect probes. Okay. So the probes are used to visualize. Okay. So we have two methods to visualize signals. We can use oscilloscope. عندنا oscilloscope in Psim, and we can use scene view. But for my opinion, using scene view is better. دوك نستعملوا also the oscilloscope. Okay. So if you want to visualize any signals, we have to add probes. For example, here the current. We have here current probe connected here. Voltage probe, of course, connected in parallel. اوكي. فور اكزومبل كي نديرو هنايا دبل كليك على الكارنت بروب واش نلقاو مكتوبه i3. اوكي. So this is the name of the variable here is i3. دبل كليك على ال voltage probe here we have VP3. So those are the names of variables. When I run simulation here كي تخلص simulation يطلعوا لي الفاريابلز تاع البروبس variable available i3 و VP3. So قد ما نحط البروبس في السيركت نتاعي يطلعوا لي الفاريابلز هنايا في السيم فيو. اوكي. So for example voltage ندير add and we can see the voltage of the rectifier. كي نحب نزيد الكارنت اوكي. So we can add them in the same graph ولا نقدروا نديروه في another graph كيما نحب. مثلا نكليكي هنايا this button here. Okay, add one on screen. Okay, so here for example هنا كي ولا select them both مع بعض وندير add نشوفهم in the same graph. هنا البروبلم برك الكارنت راهو is too small على بها مخرج دوك نعاودو نديروه وحده. اوكي. for example هنا نديرو add. Okay, so this is the current. So since the current is too small is راهو 0.02 هنا ما خرجناش مع الفولتج. اوكي معليش let's repeat ما خسرنا والو. for example let's change the value تاع الريزيستانس هذه 500 كبيره بزاف نديرو small value باش يخرج لنا الكارنت. let's make it 10 ohm. yes. Yasin, close your microphone. Yasin, close your microphone, please. Okay. So let's repeat. Okay. معليش دوك راني بدلت الفاليو تاع الريزيستانس in order to باش ما الكارنت ما يكونش too small. Okay. So as I said هادو البروبس we connect them to visualize our signals in the same view. Okay. So whatever هنا الفاريبل تاعي نسميه current for example. This one let's name it load voltage. I found it with this name in SimView. When I run simulation here, I found current, I found load voltage. If you want to display them in the same graph, I select them both, current, load voltage. Okay. Okay. So here we can see them in the same graph. If you want to see them separated, we have this button here. Okay, add one screen. Let's here plot the voltage alone. Then, for example, plot the current alone. Okay. So using this with SimView, so this SimView is used to visualize the signals, and we have different properties. For example, here we can have FFT to calculate, for example, harmonics. We can change those graphs to data, to tables, for example. We can change their colors. We can edit them, however, and send them to Word or any. For example, we can plot the XY plot. Okay. So this is the SimView. So SimView is not complicated. It's just used to display. So we have also here THD, total harmonic distortion, power factor also. How we can calculate the power factor using Psim. So SimView. So SimView its role is basically for display. Okay, let's go back to Psim, or let's go back to our lab. Okay. So firstly, measure and display the input voltage waveform as shown in the figure. Measure the DC and the AC voltage using the oscilloscope. Okay, so this is, I show you the first method to display the different signals. The second method, we can use an oscilloscope. You can see here in the element bar, you can see that we have oscilloscope. This is one channel oscilloscope. This is two channels oscilloscope, and we can find here in the elements, we can find even 4 channel. Yes, here go to element, other, probes. We can find 4 channel oscilloscope. Okay, so the 1 channel and 2 channels oscilloscope, you can find it here in the element bar, and you can bring also from the element menu others, probes, even 4 channel oscilloscope. So let's use only 2 channels oscilloscope. For example, let's connect these 2 channels oscilloscope. For example, the first channel we connected to the input, the second channel we connected to the output. Then we simulate. Okay. So here, معليش ما نستعملوش the sim view. Then we use the oscilloscope. Double click. Okay. I think it's problem of ما على باليش علاش جا مقلوب هكذا. Okay. Anyway, I think we had a problem with this oscilloscope. I don't know why it's not displaying the signal correctly. Okay, so this is as oscilloscope. For example, here we have the types of the coupling AC, AC, DC. We can change also the time division, the voltage division, like the oscilloscope. But I don't know why its signal it's not displaying correctly. Let's add another probe for the input to check the input signal here. Okay, in the sim view, this is the input. Okay, so we can see that the input is a pure sine wave. Okay, I don't know why. I think we have to add the ground, I guess. I think we have ground here. I think we have to add the ground in the circuit. Okay, so it's just a problem of scale. Okay, so this is the second method how we can display different signals. Either we use sim view or we use oscilloscope. So let's connect the second channel of the output. Okay. For me, I prefer to use sim view with probes, better than using the oscilloscope. So here we can change the scale of. So we can change the scale of. Okay, so this is the input. Okay, we have choose the same scale. This is the red one is the input, and the blue one is the output voltage, is the rectified voltage. Okay, also here we can change. Okay, you can see here we can see here when we change the coupling of the signal. Okay, look at the same signal. The output signal. Look, when we change the coupling, so it appears like the signal that we have seen in the lab. Okay, so let's. Okay, are you seeing this output signal with DC and AC and GND coupling, like what we have seen in the lab? Okay, is it clear? Is it clear how we use the oscilloscope? Okay, so now about the measurement. The measurement here, we may use measurement devices instead of oscilloscope. Okay, so those, okay, let's close this one. Those displayed here are probes, voltage probe and current probe, but we have also measurement devices. Measurement device like what? Measurement devices. Let's go to element, other probes. We have DC voltmeter, okay, and we have what? We have also AC voltmeter, okay. So let's connect. Let's try to do measurement with this DC voltmeter. Then we do it with AC voltmeter. Okay. Let's connect them both. Okay. I have connected a DC and AC voltmeter. Let's run simulation. Okay, here, so this is VP-AC and VP-DC are the measurement of the AC and DC volt. Okay, so AC and DC voltmeter, let's check them. Okay, so I'm not sure how we can get numerical values. I will check it, how we can get numerical values better than graphs. Okay. Okay, probes. Wattmeter. Okay, let's see the oscilloscope. Okay, I think we cannot do measurement with this oscilloscope. Okay, so okay, that's great. Okay. Yes. Okay. So here you can see here تبعوا معايا هذه. Okay, نعود. Okay, let's repeat. Okay, let's remove those elements. So concerning measurement, we can find DC and AC voltmeter. DC and AC voltmeter. Okay, let's go to element, other probes. We can bring here DC and AC voltmeter. Look that the voltmeter is different to the probe. Okay, so probe used directly to visualize, but the voltmeter is used for measurement. For example, let's bring DC voltmeter connected here in parallel to the load. So this one is a probe and this one is a voltmeter. Double click to this voltmeter. We can tick this show probes value during simulation. So here we can, when we choose this, we can display its numerical value. So when we run simulation, we can see its numerical value. Okay, are you seeing it? Of course, if it's a DC if this DC voltmeter, it shows, of course, the average value directly. So we don't need, of course, and if it's AC voltmeter, of course, it will show the RMS value, the AC voltmeter. Okay. Okay, dokie. Okay. Show this is numerical value. So here how we can display the numerical value using DC and AC voltmeter. This is concerning measurement. So now we have seen how we can connect the circuit, how we can use probes with SimView to visualize, and I prefer this method to visualize the signals. So when we run simulation, we will have all the variables here in SimView, and we can, for example, like this, we have displayed them in the same graph, or we can plot them separately like this. You can select each one alone, and we display different load voltage, for example. We can display each signal alone. Okay. Also, for example, the current, how we can display, and we have seen how we can display different signals with oscilloscope. So we have here one channel oscilloscope, two channels oscilloscope, and we have also four channels oscilloscope. We can bring it here from others, probes, and 4-channel oscilloscope. So the oscilloscope is connected, as you know, as we have connect the scope. We have 2 channels. For example, it's work the same thing as the real oscilloscope. For example, we have here the time division, we have the voltage division, we have the coupling. For example, here we choose DC with AC coupling, and we have 2 channels. We can change their colors, for example. Okay, we can change also the position. Okay, offset here, which is the position. Okay, so it's used as real oscilloscope. Okay, so this is when you press save. I think we can save this. Yes, we can save this picture. Okay, so we have seen also how we use the oscilloscope. Also, we have seen how we use measurement devices, which are the voltmeter and DC and AC voltmeter. Let's see, for example, now how we can visualize the current in the oscilloscope. Okay, so here display the low voltage and the current waveform on the oscilloscope. So we have displayed already the current. We have displayed already the current using the current probe in the SimView. But how we can display the current in the oscilloscope? Of course, as we have done in the lab, we add a 1 ohm resistor in series. Then we take the voltage across this resistance to the oscilloscope. Okay, I think the battery of my mouse. Anyway, okay, let's use the touchpad. Okay, I think what we have done until now is clear. Let's pass to with RC load. For example, let's add a capacitor to this circuit. Let's remove those measurements. Okay. Okay. This is the output. This is the input. Okay. Now let's add a capacitor, for example, here. Capacitor in parallel with the load. So when we run a simulation, Okay, what's happened here? There is an, okay. So when you have an unconnected element, you will see an error window. So I think we have an error here. Parameters value, yes. Parameters value, I didn't set the value of the capacitor. So double click, we can set the value of the capacitor. You see here, the value here, it's in farad. Okay, so if you want to maintain it is in microfarad, you have to add 0.00. I don't know how much zero you have to add. For example, 47. Okay, so the value is directly in farad. Now let's simulate. Let's see the input voltage with the load voltage. Okay. Load voltage. I think I have done a mistake with this load voltage. Okay, dokie. So let's remove this one. Nice. Okay. So this load, this is the load voltage. Okay, you can see it. It's look like ripples. Of course, it's depend on the value of the capacitance. So let's increase the value of the capacitance and see how it affects the value of the load voltage. You see here, after increasing the value of the capacitance, you can see the ripple has been decreased. Okay, so this is the effect of the capacitor. And of course, this is a half-wave rectifier. So of course, it will have a much ripple in its output signal. So shall we continue with the full wave rectifier or shall we stop? It's up to you. Yes. Yes. Hello. Shall we continue or shall we stop? No. No, عييتوا. Okay. Yes.
Sir, I have question.
Okay. Okay. Yes.
How can we change the time, the total time to simulation? Because when I tried to do it, band signal
the
بزاف
simulation time. The simulation time. Okay. The clock. This is the clock. Simulation control. Here we have total time. For example, كي نحب أنا display more than one period. إذا حبيت display for example one period. نشوف شحال الفريكونسي نتاعي. الفريكونسي is 50 Hz. Okay. So one period شحال ندير 0.02 for example to display just one period. This is the input. This is one period. Okay. If you want to display more than one period, go to simulation control, for example, 10 periods. 0.02 اللي هي 10 periods according to my frequency of course. Okay. نشوف الانبوت signal. Okay, so this is 10 periods. So I think it's clear. Okay, so if we show the value of the probe dummy simulation, what is the exact value? I think at the end of the simulation, it will display the exact value. Okay, so I think as much as يعني قد ما راح نوريكم in this tutorial, you can learn more when you practice with your own. Okay. So it's just a description to, for example, to break the ice. You haven't used this software before, but when you start using it, you will learn more and you will find it interesting, especially for power application. Also, I recommend this software for your third year projects. You can use it. Okay. Anything what you can do with MATLAB in power electronics application, you can do it with PowerSim. So this lab I have here is just initiation. You are going to do the second lab number 2 with freewheeling diode. Okay. This is the lab, what you have to do. Experiment number 2, single phase half wave and full wave rectifier. Okay, so this is the circuit with RL load. You know, you have seen in your course when you connect the inductor in the circuit, the current became continuous. Okay, and that current caused an inverse voltage. You have seen it, I think, and you can check it by simulation. That's why we add this freewheeling diode to protect and to allow that the current keep circulating in this loop. Okay, so you do the half wave and the full wave with and without freewheeling diode. Then you can plot your graphs here and fill the table and add a conclusion. So this is the second lab. You do it by simulation. Next week, inshallah, نديرو third lab in practice. Okay. Okay, I think that's all. Okay. This presentation will be uploaded, inshallah, later on YouTube for the ones who haven't seen it. Okay, so I'm going to close the session. See you, inshallah. Okay, goodbye.